Good afternoon. The title of my presentation is Do the Visual Cues Influence Annoyance Perception of Sounds? The work was done in a team with Natalia Dybionka, Jan Felsen and Paweł Gogoliński, students and researchers from our university. The aim of the study is to determine whether the visual information about the distance of an object seen in the video changes the assessment of annoyance only based on the auditory information. The annoyance of 4 different noise sources were assessed. The noise sources studied were passenger train, passenger car, wind turbine and fontaine. Original video recordings were made at 3 different distances. The equipment that we used to record the audiovisual stimuli consisted of an ambisonic microphone and a high-definition Canon camera. 2 of our noise sources were moving with different speed. You can see car and train. And 2 others were stationary, although the wind turbine blades were moving, but it was a different type of movement. Please notice that there were different height of these noise sources, from 1.5 meter until 160 meters. It should be mentioned here that we did not use the originally recorded sound levels. Our audio samples were presented to the participants in our experiment at 3 sound levels, 45, 55 and 65 dBA. This was the only way to test how distance of the object seen in the video affects annoyance ratings of the stimuli presented at the same level. Well, as you saw on the previous slide, the height of these noise sources were different. So to find the proper method for defining the 3 possible distances, we made an initial assumption that at the optimal distance, the maximum size of an object contour is still entirely visible on the screen. And this condition was fulfilled at 3 meters for car, at 7 meters for train, 9 meters for fontaine, and 200 meters for the wind turbine noise source. To define the next step in distance, we use the well-known Weber fraction law. We have chosen K index equal 0.04, the same fraction which is responsible for the line length discrimination. The assessment of the audiovisual annoyance were carried out in laboratory settings in 3 different experiments. In experiment 1, the audio samples were presented to our participant at 3 different sound levels. In experiment 2, video samples were presented to our participant at 3 distances. Finally, in experiment 3, audio-visual samples were presented at 3 sound levels and at 3 distances. 30 people, 14 males and 16 females, participate in all 3 experiments. The reproduction of the stimuli took place in an anechoic chamber. The configuration in an anechoic chamber consists of 25 loudspeaker and 1 subwoofer. On the next slide you will see the instruction which was given to our participants in each experiment. In experiment 1, where we presented audio samples to our participants, the instruction was as follows. Imagine that you want to relax in the presented conditions. Rate how annoying the presented noise is for you. You will be rating on the scale from 0 to 10, where 0 means not annoying at all, and 10 means extremely annoying. In experiment 2, where we presented video samples for our participants, the instruction was: imagine that you want to relax in the presented condition. Rate how annoying the presented video is for you. And in experiment 3, when we presented audio-visual samples, imagine that you want to relax in the presented condition. Rate how annoying the presented audio-visual stimulus is for you. Of course, the numbers mentioned in experiment 1 was the same in experiment 2 and experiment 3. Before I will tell you about the results of our first experiment, I will tell you how we calculate the data. In each experiment, all stimuli were rated 3 times by each participant. The median value was calculated from each of the 3 values, and then used as a participant's response. In this way, the data was aggregated before statistical analysis. Then the results were calculated in an R environment using bootstrapped confidence intervals. And by using this method, we got such a result in experiment 1. On the y-axis you have mean annoyance rating, average over subjects, and on the x-axis you have different sound level L3, L2, L1. This statistical analysis reveals significant differences between the means of the annoyance ratings of sound level L1, here, L1, for all the pairs, including the fontaine and one of the sound sources. So fontaine and one of the other sources. For the sound level L2, there were no statistical differences between different noise sources, and for the sound level L3, the difference occurs only between car and train and car and wind turbine. Now let's talk about the results in experiment 2, where visual stimuli were presented. Here you can see that the annoyance rating creates two subsets. The one subset is for moving sound sources and noise sources, and the other one for stationary noise sources. And actually there is significant difference between these two subsets. However, there are no statistically significant differences in annoyance ratings for all noise sources for all distances, with one exception, car. This can be seen here. Between D1 and D3 there is a significant difference. On the next two slides you will see the results of our 3 experiments presented in total. So these 2 columns are for the moving noise sources, for the car and for the train. And again, on the y-axis you have mean annoyance ratings, and on x-axis you have A, means audio, experiment 1, V, visual, experiment 2, and audio-visual, experiment 3. And in each column, each row means different level. Sound level 1, sound level 2, sound level 3. And what you can see from this figure that actually the mean annoyance ratings obtained for audio-visual modality follows the assessment from audio modality only, so they are actually the same. The different values obtained for visual do not follow the results in audio-visual modality. The same you can obtain for train. And if we look at the next figure, then we have stationary noise sources, fontaine and wind turbine. And here also the mean annoyance rating obtained for audio experiment 1 agree with the mean annoyance rating obtained for audio-visual modality. However, there is strange difference here. For example, for level 3, you can see that in a visual modality, the annoyance rating are extremely low comparing to the audio-visual modality and audio modality. But still, there is an agreement between audio and audio-visual modality, and actually we can say that visual modality is neglected. And a similar situation occurs for the wind turbine. Finally, we can look at the experiment third in a different way, comparing the results of audio and audio-visual stimuli. And here you have on the y-axis mean annoyance ratings, and on the x-axis you have noise sources. And with circle we have audio modality, and triangle means audio-visual modality. And colors means different level L1, L2, L3. What is interesting here, that actually there are no statistical significant differences between annoyance rating of the stimuli presented in the audio and audio-visual experimental conditions for all investigated noise sources, except the wind turbine presented at sound level L3. Here you can see the difference at this point. So the mean annoyance rating is lower for the audio-visual modality than for the audio modality only. But in other cases, there is no significant difference between these two modalities. What's more, you can see from this picture that there is kind of ranking of annoyance, which depends on the noise source. And for L1 and L2, the least annoying noise source is fontaine, and the other three noise sources are assessed in the same way. Annoyance is almost equal. The situation is different when it comes to L3. So for L3 in audio modality, the car and fontaine are less annoying than train and wind turbine, while in audio-visual modality, the car is less annoying than all the others. But what is also interesting in this figure, we can observe that there is a lower 95% confidence intervals in audio-visual stimuli than in audio stimuli. What does it mean? Probably people are more precise in their annoyance judgment when both audio and visual information are presented to them than when only audio information is evaluable. So let's come to conclusions. So the first main conclusion is that results show that visual information, the distance, does not have an effect on the annoyance ratings of environmental audio-visual stimuli, with one exception: wind turbine presented at sound level 65 dBA. Next one, in an audio-visual sample, the audio information is more important than the visual information. Next, the annoyance associated with audio-visual stimuli ratings follows the annoyance ratings obtained for audio stimuli only and ignores the results obtained in visual condition only. And finally, a conclusion is that if the audio part of the stimulus has a relatively higher sound level, this visual information is neglected. Thank you for your listening.